Hello my friends and welcome back to the You Can Do TV channel. Taj Cure is the best tannery in Fez, Morocco, famous for its high-quality leather and centuries-old craftsmanship. Located in the historic Medina, Taj Cure tans cow, goat, and sheep hides using traditional techniques combined with modern processes. The tannery produces various leather types, such as full-grain, crust, nubuck, and suede, suitable for luxury bags, shoes, belts, and garments. One of the key strengths of Taj Cure is its use of advanced leather pressing machines during the tanning process. These machines ensure uniform thickness, compact fiber structure, and enhanced surface smoothness, critical factors in creating durable, high-quality leather. After tanning with natural plant-based tannins or a hybrid formula, the hides are passed through hydraulic presses, which remove excess moisture and help fix the tanning agents deep into the fibers. This eco-friendly process enhances the durability, softness, and natural beauty of the leather. After tanning, the hides are stretched on frames to dry evenly and prevent shrinkage. This stretching stage is essential for maintaining the shape and quality of the final leather. To enhance appearance and durability, Taj Cure applies surface finishing techniques including spray dyeing. A fine layer of color or protective coating is sprayed evenly across the leather surface, enriching its tone and providing water resistance and UV protection. With a perfect blend of heritage and technology, Taj Cure remains a symbol of Moroccan leather excellence, offering products that reflect authenticity, sustainability, and masterful design. At the heart of Bologna, Italy, the Enzo Bonafé atelier is a model of technical mastery in traditional shoemaking. Every pair is crafted entirely by hand, using time-honored methods that ensure durability, precision, and artisanal integrity. The process begins with a selection of premium leathers, such as full-grain calf, shell cordovan, or exotic skins. These are meticulously hand-cut for optimal grain alignment and pattern symmetry. Bonafé specializes in high-level constructions, including Goodyear welt, Norwegian Norvegese, and hand-sewn Bologna construction. Goodyear welt involves a welt strip stitched to both the upper and insole, allowing resoling without compromising the structure. Norwegian construction features visible welt stitching around the shoe perimeter, ideal for water resistance and structural rigidity. Bologna construction offers flexibility, using tubular stitching techniques for a glove-like fit. The lasting process is done by hand, ensuring exact shaping to the last. Soles are stitched with waxed linen thread using antique machines, and the heel stack is manually built layer by layer for balance and weight distribution. Each shoe undergoes hand finishing, including burnishing, polishing, and edge dyeing to achieve a bespoke level appearance. Final inspection ensures precise alignment, stitch density, and uniform tension. With over 300 technical steps per pair, Enzo Bonafé preserves Italy's shoemaking heritage while delivering unmatched functional elegance. The atelier's commitment to structural integrity and technical perfection defines its global reputation. The creation of a handmade luxury bag from goatskin begins with the careful selection of premium hides. Goatskin is chosen for its fine grain, flexibility, and tensile strength, making it ideal for high-end leather goods. The selected leather is conditioned, inspected, and precisely cut using rigid templates to ensure uniformity across components. Edges along folds and seams are skived to reduce bulk, allowing for clean construction and refined lines. Reinforcement materials such as leatherboard or canvas are inserted between outer layers and linings to provide structural support without compromising flexibility. All pieces are glued using water-based adhesives and allowed to cure before further processing. The strap, bag handle, is prepared from a stiffer section of goatskin. It is cut to length, skived along the fold, and assembled around a reinforcement core. Once shaped, the strap is glued, clamped, and hand-stitched using the saddle stitch method with waxed linen thread. Edges are finished using burnishing techniques, followed by the application of multiple coats of edge paint, sanded and sealed for durability. For higher-end finishes, heat creasing with a fileteuse is used to define borders. Attachment points for the strap are reinforced with internal backing and secured using stainless steel hardware such as D-rings, rivets, or clasps. Placement is measured precisely to ensure even weight distribution. Stitch holes are marked using pricking irons and hand punch to maintain consistent spacing. The main body of the bag is assembled panel by panel, with hand stitching used throughout. The interior lining, often made of lambskin, calfskin, or fine textile, is inserted with folded seams for a clean, concealed finish. Internal pockets are added, and closure systems such as magnetic snaps or zippers are installed. Final finishing includes thorough inspection, edge polishing, and surface treatment with wax or conditioner. The result is a durable, visually refined bag that reflects traditional craftsmanship and technical precision in every detail. The making of a handmade, lined, and raised leather belt is a meticulous process rooted in traditional saddlery techniques. Crafted from premium bridle leather, each strap is first straightened and cut to precise dimensions using hardened strap cutters. The belt is constructed with a raised central core, flanked by 2 outer layers of leather, and lined on the underside for comfort and durability. Edges are shaved and hand-creased, then finished with multiple layers of edge dye and wax, burnished to a smooth, rounded profile. Sizing and hole placement are carefully calculated and punched, and keepers, either leather or solid brass, are cut and stitched. Pricking irons mark uniform stitching holes, and the belt is hand-stitched using a traditional saddle stitch with waxed linen thread totaling nearly 1,000 stitches per belt. A carefully selected solid brass buckle is attached and stitched into place. The result is a robust, timeless belt, crafted by hand, built to last, and finished to perfection. The Lloyd Coat wallet is a refined leather accessory rooted in mid-century design. Inspired by a 1950s wallet, its modern adaptation preserves the elegant original lines while accommodating today's essentials. Precision begins with selecting the right leather for the outer shell, lining, and inner layers. Pattern making is crucial, as the complex layout demands accuracy for seamless assembly. Each component is hand-cut, glued, and assembled using traditional saddlery tools. Prick marking, normal, reverse, and inverse, is carefully applied to prepare for saddle stitching, performed entirely by hand for durability and aesthetics. Edges are shaped using a fileteuse, then dyed and burnished for a polished finish. The process follows a meticulous pattern of work specific to coat wallets, with detailed attention given to every card slot and fold. Each wallet takes over a full day to produce, blending heritage craftsmanship with functional elegance. Take a glimpse into the workshop where a handmade alligator watch strap is crafted from start to finish, using traditional saddler and cellier techniques. The process begins with selecting the right materials: premium alligator leather for the outer, vegetable tanned calf or zermatt leather for the lining, and a durable reinforcement layer for structural integrity. Each layer is chosen for its thickness, temper, and sweat resistance. Using precision templates, the strap is carefully patterned and cut. The leather is then thinned, skeeved, at key areas, such as the fold and tip, to ensure elegant, clean lines and flexibility. Correct sizing is essential and varies based on wrist measurements, watch lug width, and buckle style. The layers are glued together using water-based adhesives, and the strap is assembled in a set sequence. Pricking irons mark out the stitch holes, which are then hand-stitched using a saddle stitch with waxed linen thread for maximum durability and visual symmetry. For edge finishing, the strap is burnished, shaped with a fileteuse, edge creaser, and built up with multiple layers of edge paint for a smooth, glossy finish. Holes are measured and punched with precision, and keepers' loops are crafted and fitted. Finally, a carefully chosen buckle is installed. The result is a strap that balances strength, comfort, and timeless elegance. With tools like a skeeving knife, awl, edge beveler, and creaser, the work is deceptively simple, but demands immense precision. Handmade straps like this are not about logos. They are about legacy, skill, and passion. In the small town near Saint-Julien-Genevois, French artisan Patrick Collard transforms goose and ostrich eggs into intricate sculptural lamps under the name Tix Art. His craft, combining artistic vision with remarkable precision, involves a highly detailed multi-day process that turns fragile eggshells into luminous decorative objects, using precise punctures to allow internal contents to be extracted without cracking the shell. Once empty, the egg is soaked for several days to cleanse the interior. Collard uses diamond burrs and rotary tools to enlarge the drainage holes, later used for electrical fittings. Next comes drawing and geometric layout. The egg is carefully divided into 12 vertical sections and marked with circles to guide the pattern. Patterns, either figurative or geometric, are drawn and then marked using fine engraving techniques. This phase is time-consuming and requires extreme delicacy. Even a small mistake with the rotary tool can shatter the shell. Sculpting begins with surface carving and deep engraving. Sections are pierced and textured using rotary burrs. Ostrich eggshells, with thicknesses up to 2 mm, are preferred for more advanced sculptures and lighting applications. In some cases, the shell is lightly etched with acid to thin the surface and ease carving. To achieve translucent light effects, areas are selectively thinned to about 0.25 mm, allowing internal illumination to shine through. These zones are shaped into motifs such as leaves, with engraved veins enhancing the detail. Internal membranes are removed to detect flaws and allow uniform light transmission. Once carving is completed, the shell is soaked in detergent and thoroughly cleaned, then varnished and mounted with custom stainless fittings and light sockets. Each sculpted egg takes 60+ hours to complete, depending on complexity. Colloud's work is displayed in exhibitions and artisan fairs, where the transparent, glowing eggshell sculptures showcase an exceptional fusion of craft, precision, and imagination. The manufacturing process of export-quality safety matches is a streamlined operation that blends mechanical precision with essential safety standards. It begins with box making, where cardboard or duplex boards are cut, folded, and printed to create matchboxes. Simultaneously, stick selecting takes place, where wooden splints are chosen for uniformity in length, thickness, and straightness. Defective pieces are removed during the stick rejecting phase, ensuring only quality splints continue. Next, in the stick process, the selected splints are fed into the dipping unit, where one end is coated with a specially formulated match head mixture, typically consisting of potassium chlorate, sulfur, glass powder, and coloring agents. After drying, the matches are aligned and counted automatically for accuracy in the number of stick counting phase. They are then placed into prepared boxes during packing, sealed, and stacked. Once completed, the matches are ready for dispatch, meeting export-grade standards. Devonia Sheepskins is a renowned tannery based in southwest England, specializing in the traditional tanning of British sheep hides. With a heritage spanning over 200 years, Devonia is one of the last remaining tanneries in the UK, still producing sheepskins through time-honored techniques that preserve the natural character and quality of the wool and leather. Each hide is cleaned, soaked, and limed before undergoing a gentle tanning process using environmentally friendly agents. Unlike mass production, Devonia's approach is slow and deliberate, ensuring softness, durability, and warmth in every sheepskin. Once tanned, the hides are dried and finished by hand. The wool is brushed, trimmed, and left in its natural cream or dyed to various shades using non-toxic dyes. The leather side is often buffed or suede finished, giving a luxurious feel and excellent breathability. Devonia sheepskins are widely used in interiors, fashion, and upholstery, valued for their softness, resilience, and sustainable origin. With every stage managed in-house, the company ensures quality control and traceability from farm to finished product. Devonia stands as a symbol of British craftsmanship, natural material use, and ecological responsibility. The manufacturing of Axminster carpets is a precise and highly technical process that combines traditional craftsmanship with modern machinery. Known for their durability and intricate patterns, Axminster carpets are woven using a unique method where the pile yarn is inserted and woven simultaneously with the backing yarns. The process begins with yarn preparation. Wool, often blended with nylon for added strength, is dyed in large vats to achieve the desired colors. Once dyed, the yarns are dried and wound onto cones, ready for weaving. Weaving is carried out on special Axminster looms. Unlike tufted carpets, where yarns are stitched into a backing, Axminster weaving involves individual tufts of yarn being selected, cut to size, and inserted into the weave in a precise sequence to form the pattern. Each tuft is woven into the backing, creating an interlocked structure that is strong and dimensionally stable. This technique allows for complex and colorful designs, making Axminster carpets ideal for high-end commercial and hospitality settings. After weaving, the carpet undergoes finishing processes. This includes shearing to ensure a uniform surface height, backing treatments for stability, and inspection for defects. The finished carpet is then rolled, labeled, and prepared for shipment. Axminster carpets are prized for their long life, resistance to wear, and design versatility. Their manufacturing involves a balance of automated precision and artisan knowledge, ensuring both quality and customizability. Whether for luxury hotels, theaters, or historic buildings, Axminster carpets continue to represent the pinnacle of woven carpet engineering. This process showcases not just textile production, but a refined tradition that has evolved over centuries to meet modern performance and aesthetic standards. The Butterfly Tapestry, designed by Alison Watt and woven at Goatkin Studios, Edinburgh, is a masterpiece of technical and artistic achievement. Created over 18 months by master weaver Naomi Robertson, it employs traditional hand-weaving techniques on a vertical high warp loom. Wool and cotton yarns were meticulously dyed and blended to achieve subtle tonal shifts, capturing Watt's delicate brushwork in woven form. Measuring across 3 floors of Glasgow's Theatre Royal Foyer, the work required detailed cartoon scaling, precise color mapping, and thousands of hours of weaving. The result merges fine art with textile precision, Scotland's largest tapestry installation in a public space. An automatic pattern sewing machine is used for stitching leather car seat covers with high precision and efficiency. This heavy-duty machine is ideal for thick materials, ensuring perfect stitch quality even with heavy threads. It operates strictly according to preset pattern designs, delivering uniform and consistent stitching across the surface. The machine features excellent thread tightening mechanisms, preventing loose or uneven seams. Its advanced automation allows for accurate and repeatable sewing on complex patterns, increasing productivity while maintaining premium craftsmanship. This solution is widely used in automotive upholstery manufacturing for durable and aesthetically precise seat cover production. The Cushion Pillowcase automatic sewing machine with Autoloader is designed for high-efficiency textile production. It automatically loads fabric templates and performs precise sewing operations using programmable patterns. The machine supports straight stitches, back stitches, and zigzag stitches, specifically useful for reinforcing tie string areas. This setup ensures consistent stitch quality, accurate alignment, and reduced manual labor. Ideal for sewing cushion and pillowcases, the system improves productivity and maintains uniformity across large production batches. The Autoloader function enhances workflow by feeding materials continuously, making it a reliable solution for modern sewing lines. The factory mattress production process begins with quilting the top panel using the Richpiece automatic single-needle quilting machine, operating at speeds of up to 3,000 revolutions per minute. Patterns are designed via Richpiece QuiltCAD software and executed automatically. For mattress borders, a multi-needle chain-stitch quilting machine produces precise quilted layers. Following quilting, components like the spring unit are prepared and aligned. The mattress is then assembled, including stitching the quilted panels, inserting the spring core, and securing all layers. Final border sewing completes the structure, resulting in a fully assembled, factory-made mattress ready for packaging and distribution. Wellgreen Pillow Manufacturing Unit specializes in high-quality pillow production using advanced machinery and standardized processes. The facility handles fiber filling, stitching, shape forming, and quality inspection with precision. Automated equipment ensures consistency, while rigorous checks guarantee comfort, durability, and hygiene in every finished pillow product. At Company C, each piece of custom upholstered furniture is crafted individually by skilled artisans using time-honored techniques and premium materials. The frames are constructed from kiln-dried and engineered hardwoods, ensuring durability and resistance to warping. Joints are precisely glued and double-doweled, then reinforced with angled corner blocks to provide superior structural strength. The seating foundation features the 8-way hand tying method, where each coil is tied to the frame at 8 points using premium no-squeak twine, delivering long-lasting comfort and support. Every piece is hand-cut, hand-sewn, and hand-tailored, showcasing true craftsmanship. Artisans meticulously align fabric patterns from top to bottom and side to side, ensuring seamless visual continuity. Whether patterned or solid, the fabric placement is executed with precision for a clean, cohesive look. Company C's commitment to detail and traditional construction methods ensures that every custom piece is both aesthetic and functional, built to last and tailored to reflect individual style. Glass production is a precise and fascinating process. It begins with raw materials like sand, soda ash, limestone, and recycled glass, all melted at around 1,500 degrees Celsius. The molten glass is then shaped into bottles or jars using industrial machines and compressed air, not by mouth blowing, as in the past. Each container is reheated, annealed, and quality checked individually. At plants like those in Béziers and Lannion, over 1 million bottles or jars are produced daily. Thanks to recycling, glass can be reused endlessly, making it both efficient and environmentally friendly. Saudi Plastic Factory Co. (SPF) operates a highly integrated plastic manufacturing facility, specializing in advanced blow molding and injection molding technologies. The blow molding department handles container production ranging from 0.05 liters to 30 liters, utilizing automated systems to ensure consistent wall thickness, high dimensional stability, and uniform material distribution for both industrial and commercial packaging. In parallel, the injection molding division is equipped with machines ranging from 50 to 1,000 tons of clamping force, supporting high-volume output of precision molded parts. This includes in-mold labeling, IML containers for the food industry, combining visual appeal with barrier protection and compliance to hygiene standards. These containers are produced with tight tolerances, smooth finishes, and integration of printed labels during the molding cycle for durability and traceability. SPF also manufactures U-shape and Z-shape drinking straws, applying extrusion and forming technologies to produce flexible, food-grade straws at industrial scale. Using modern printing technology, the factory delivers high-quality commercial product branding directly onto plastic surfaces, enhancing shelf presence. The facility's commitment to automation, quality control, and scalable production allows SPF to serve a wide range of industries, from FMCG to logistics, while maintaining efficiency and product consistency. The Trigger spray pump capping machine with ABB 1200 and PE robot integration is an advanced all-in-one solution designed for efficiency and flexibility. Featuring a quick change component system, it allows for fast adaptation to various pump sizes. The robotic arms ensure precise alignment and secure capping, improving consistency and reducing manual handling. Operating at a capacity of 20 to 30 bottles per minute, it offers optimal performance for medium-speed production lines. Viglo operates a 110,000 square meters advanced manufacturing facility in India, specializing in high-precision caps and closures. The factory utilizes fully automated, high-speed injection molding systems equipped with high cavitation molds to ensure consistent output and minimal cycle times. Robotic handling, in-mold labeling, and precision assembly systems enable the production of multi-component closures such as lotion pumps, mist sprays, and disc tops. The plant integrates state-of-the-art vision inspection systems to guarantee dimensional accuracy and product integrity. Viglo's zero-waste approach includes closed-loop material recovery and energy-efficient machines, making their production both technically advanced and environmentally responsible. The cheese-making process begins with fresh milk, which is pasteurized to eliminate any harmful bacteria while preserving essential nutrients. This step is crucial for ensuring product safety and quality. Once pasteurization is complete, cheesemakers add specific starter cultures, beneficial bacteria that help develop the cheese's flavor, and rennet, an enzyme that causes the milk to coagulate into a soft, gel-like curd. The curd is then cut, stirred, and gently heated to separate it from the whey. Gaiden operators oversee the next steps, ensuring the curds are properly drained and molded. After molding, the cheese is salted, either by rubbing or brining, to enhance flavor and act as a preservative. The formed cheese is packed into wooden boxes and transferred to maturing rooms, where it ages under controlled temperature and humidity. Production operatives monitor conditions and rotate the cheese to ensure uniform ripening. Finally, matured cheese is portioned, labeled, and prepared for sale by retail assistants, completing the journey from farm-fresh milk to finished, ready-to-eat product. Wisconsin, with its lush pastures and pure limestone filtered water, has long been a hub of artisanal cheesemaking. Rooted in European tradition, the craft began with immigrant cheesemakers seeking ideal conditions for producing high-quality cheeses. Today, both large-scale and small family-run plants in Wisconsin uphold this legacy with a mix of modern science and time-honored techniques. Cheesemaking starts with fresh milk, tested and adjusted for fat content depending on the cheese variety. Starter cultures, such as Streptococcus and Lactobacillus, convert lactose into lactic acid, creating the right acidity for adding rennet, which coagulates the milk into curds and whey. The curds are then cut, heated, and manipulated according to the cheese style. Soft cheeses retain more moisture, while firmer cheeses like Parmesan require higher temperatures and longer pressing. Processes like cheddaring, knitting, and salting follow, each critical in shaping flavor and texture. Curing or aging, sometimes lasting years, is the final step, developing complexity and depth in the cheese. Wisconsin leads the U.S. in cheesemaking standards, licensing, and education, including the elite Wisconsin Master Cheesemaker Program. With over 600 varieties produced, Wisconsin remains the benchmark for quality, craftsmanship, and dedication in the world of cheese. Vatalal's ice cream manufacturing process is a precision-engineered system that integrates hygienic design, temperature control, and high-throughput automation. The process starts with chilled milk, collected below 5 degrees Celsius, and stored in sanitary-grade stainless steel silos. In the tri-blender, cream, sugar, stabilizers, emulsifiers, and skimmed milk powder are mixed at 60 degrees Celsius, forming a uniform premix. The mixture undergoes HTST pasteurization at 82 degrees Celsius for 16 seconds, then passes through a two-stage homogenizer to ensure fat globule reduction, yielding a creamy mouthfeel. The chilled mix is aged and transferred through CIP-compliant pipelines into flavor blending units. For cones, robotic units dispense the mix into chocolate-coated cones. Ice cream is layered with syrups or inclusions via servo-controlled nozzles. Lids are automatically placed and sealed using pick-and-place robotic arms before the product enters a -40 degrees Celsius blast freezer for rapid hardening, preserving microcrystalline structure. Stick lines utilize extrusion freezing technology, where twin flavor profiles are shaped, sliced, and inserted with sticks in a continuous motion. Products like kulfi are filled into molds, flash frozen, and demolded using hot air. Each production line includes real-time quality monitoring, from overrun control to viscosity. Vatalal's BRC-certified facilities rely on tamper-proof cold chain logistics, ensuring optimal product integrity from plant to shelf. The manufacturing of sunglasses is a meticulous and technically advanced process that combines modern automation with precision craftsmanship. In leading factories across China, the production of high-quality eyewear begins with innovative design and follows through a series of controlled steps to ensure durability, style, and optical performance. Each pair of sunglasses is the result of coordinated processes that transform raw materials into finished fashion and safety accessories. The process starts with detailed 2D and 3D CAD drawings, defining the shape, curvature, and structural features of the frames. These designs guide the creation of precision molds used in injection molding, where high-grade plastics or acetates are formed into frame components under tight quality controls. Once molded, the parts are polished and tumbled to remove rough edges and achieve a uniform surface finish. Following this, components are cleaned and dried before proceeding to color painting and optional double injection processes, which allow for complex two-tone effects or added texture. Branding is applied through logo printing using pad or laser methods. Parallel to this, lens production includes cutting, UV coating, and visual inspection. Lenses are assembled into the frames with high precision, and the final products undergo strict tests for fit, appearance, and optical performance. Each unit is then packed according to export standards. The integration of digital design, high-speed machinery, and hands-on inspection ensures that each pair of sunglasses meets international quality expectations. The production of acetate sunglasses combines craftsmanship with advanced precision techniques to achieve high-quality, fashionable eyewear. The process begins with the design phase, where frame styles and dimensions are defined digitally. These designs are then transferred to a CNC machining center, which precisely cuts and carves the front frame and temples from high-grade acetate sheets. The frame curvature is formed during curved frame shaping, while stitching temples and welding nose pads solidify the structural assembly. Key mechanical steps follow, including thrusting needle insertion, temple cutting, notching, and spot welding of hinges. Tumbling and polishing are critical to smoothing the acetate surfaces, ensuring the sunglasses are comfortable to wear and visually flawless. Milling grooves are created to securely hold the lenses. Further, temple polishing, temple curving, and screwing reinforce the product's structure and finish. Branding and aesthetic enhancements come next. This includes pad printing, gilding, laser engraving, screen printing, and heat transfer printing, depending on brand identity requirements. These techniques mark logos or decorative patterns precisely onto the frame. Lens cutting is performed with accuracy to match the frame curvature, followed by lens fitting and pressure adjustment at pressure part stations. The final product undergoes a rigorous quality inspection to check for defects in alignment, surface finish, printing clarity, and lens integrity. Lastly, the sunglasses are cleaned during the wiping stage, labeled, and packed securely for distribution. Each step of the acetate sunglasses manufacturing process, from raw acetate shaping to high-precision assembly and branding, ensures that the final product meets both performance and aesthetic standards expected in premium eyewear. The condom production process begins with model cleaning, using 80 degrees Celsius hot water spray and brushes, followed by model drying at 60 to 100 degrees Celsius, and cooling at 30 to 50 degrees Celsius. The first latex immersion is carried out at 28 to 38 degrees Celsius to a depth of 230 millimeters, plus or minus 2 millimeters. After another model cleaning cycle, a third latex soaking is performed under the same conditions. Def 10. Next, roll edging is done using steam and rubber rollers. The dipped molds are then dried at 90 to 120 degrees Celsius, followed by ammonia immersion, 45 to 65 degrees Celsius, 0.2 to 0.4% ammonia content. Once dried, water flushing into molding are conducted using soap with 8 to 12% anti-sticking agent and a white carbon black suspension, 2.5 to 3.5% isolating agent. Semi-finished condoms are collected and undergo centrifugal dewatering before being organized and dried. Each unit is tested using blasting detection to ensure durability and safety. Finally, products are packaged as finished goods, ready for distribution. Glasco's advanced manufacturing of Boro 3.3 laboratory glassware is driven by high-capacity, precision-engineered systems. The facility houses 105 automated blowers, supporting 2.7 million single-chuck and 2.5 million double-chuck units annually. A dedicated hand-blowing section adds artisanal control for niche items. Their CNC glass machining unit, with over 80 specialized machines, ensures dimensional accuracy for critical components like volumetric flasks and measuring cylinders. Automated amber coating, hot vision camera inspection, and ceramic ink printing lines enable uniform finishes, identification, and traceability. A Class 100,000 cleanroom handles sterile production, while NABL-accredited calibration labs maintain tolerance compliance. Glasco's 13,000-liter oxygen tank system and furnaces handling 1,850 ton per year of raw borosilicate ensure stable, high-purity melts. With automated dropper assembly, QR-coded traceability, and filtered glassware production, Glasco delivers consistent, regulation-grade laboratory glass for global scientific applications. The manufacturing process of toys involves a series of highly controlled technical stages to ensure both product functionality and child safety. It begins with injection molding, where plastic resins are melted and injected into precision-engineered molds to form toy components. These parts then undergo pad printing or stickering, applying decorative elements and branding using high-accuracy machines. During the assembly phase, components are fitted together, often using ultrasonic welding to fuse plastic parts without adhesives, creating durable and seamless joints. To maintain quality throughout production, in-process checks are conducted at various stages, verifying dimensional accuracy, surface finish, and structural integrity. Once assembly is complete, toys are packed using protective materials to preserve quality during shipping and storage. A critical part of the process is product testing. Each toy must pass a series of safety evaluations according to international standards. These include sharp edge and point tests, small ball tests, and accessibility tests to identify choking or injury hazards. Mechanical durability is tested through torque, tension, and compression tests, while drop tests simulate impacts from falls. Further assessments such as reasonably foreseeable abuse, plastic film thickness, and sound pressure level measurements ensure toys are safe for extended and varied use by children. Saint-Gobain formula plays a key role in the ceramic tableware industry by supplying high-performance plasters specifically designed for slip casting and jiggering processes. In mold making, A homogeneous plaster slurry is prepared to ensure excellent workability, with controlled expansion delivering precise dimensional accuracy. These case mold plasters offer high strength, ensuring durability throughout production cycles. During slip casting, Saint-Gobain's innovative plaster technology provides an optimal balance between absorption capability and mechanical strength, resulting in smooth, defect-free, green-piece surfaces. This ensures consistent shaping and quality for hollow ceramic wares. In jiggering, where rotary shaping is applied, the plaster must exhibit high permeability and mechanical integrity for precise and durable reproduction of profiles. Saint-Gobain's specialized plasters ensure detailed shape transfer with minimal deformation. Each product is tailored through performance evaluation to meet customer requirements, offering both technical advantage and cost efficiency. Handmade Italian Glass is Europe's leading float glass manufacturer, producing around 9 miles of glass daily at its Yorkshire facility. The process begins by melting sand, soda ash, limestone, and recycled glass at 1,500 degrees Celsius. Molten glass flows over a tin bath, then cools slowly in an annealing layer to relieve internal stresses. Advanced laser systems inspect for defects before cutting. Some glass undergoes magnetron coating, adding microscopic metal oxide layers that enhance energy efficiency and solar control. Laminated glass is also produced by bonding a PVB layer between glass sheets, improving safety and UV protection. Handmade Italian uses 30% recycled glass, saving 375,000 tons of carbon dioxide yearly. In the world of high-precision rubber manufacturing, Nandini Rubber Incorporated stands as a benchmark of quality and innovation. From humble beginnings to a state-of-the-art facility, the company has mastered the science of rubber compounding and molding, delivering components that meet the most demanding industrial standards. This is where technology, craftsmanship, and performance converge. Raw material management is conducted using a FIFO system, with temperature and humidity-controlled cold storage for rubber and chemicals. Automated weighing systems ensure precise dosing of inputs like carbon black and processing oils. These ingredients are batch-fed into a PLC-controlled kneader, which regulates time, temperature, and pressure during compounding. The refined rubber is then processed in mixing mills, where curatives are added under monitored conditions. Mills are fitted with safety systems, including emergency stops and reverse drive capabilities. Dedicated color batch mixing prevents contamination, and mixed compounds are aged under controlled conditions before release. All batches are lab tested for hardness, tensile strength, and elongation. Semi-automatic cutting machines ensure weight consistency, minimizing molding defects. Advanced hydraulic and vacuum presses mold precision parts such as HD caps and grommets, with PLC-controlled curing parameters. Extrusion lines manufacture rubber tubes and profiles, vulcanized in autoclaves, and cut to size. Post-molding operations include trimming, deflashing, and post-curing. High-voltage testing verifies insulation properties of critical components. Dimensional checks use profile projectors, verniers, and pin gauges. Packaging involves digital counting and barcode labeling. The tool room features milling, drilling, and grinding equipment operated by experienced engineers. With ISO TS 16949 certification, Nandini Rubber maintains stringent quality controls and training programs. Ongoing expansion aims to position the company as a Tier 1 supplier to global automotive OEMs with a focus on quality, precision, and delivery reliability.